Welcome to the video using MedFOS-P. In this video, I'm going to give you an overview of MedFOS-P and how it's different from regular MedFOS. We're going to discuss the special options that come with MedFOS-P that are different. We're going to run the simulation, and we're also going to look at the program output. And this time I promise we're also going to look at how to get help. So to get started, let's go under the Start menu, over to All Programs, to the MedFOS installation shortcut. And we have a shortcut here for a GUI from MedFOS-P. So we'll click on that. And we should see something that's very similar to the GUI we saw for MedFOS, because they're both handled by the same GUI liner software. So again, we have the options here on the left, we have a main pane, and we have a console and error area on the bottom. MedFOS-P is different from MedFOS because instead of setting single values for some of the parameters, you can now set ranges for those values. So for instance, the initial population size, instead of being a single value, can now take a minimum and a maximum. And then what MedFOS-P can do is run tens, hundreds, thousands, or tens of thousands of simulations, randomly selecting single parameter values from those ranges, and then aggregate the results for you so that you can understand how outbreaks would behave as parameters varied. This is quite different from running a single simulation under MedFOS with a single set of parameters, and much more useful. So all of the options you see on the left here that include an asterisk will accept a range of values and not just a single value. There are still some that only accept a single value, but there are many now that have an asterisk, and where you can include minima and maxima for each. So again, as before, we're going to load an XML file to get us going a little bit quicker. Go to the installation directory for MedFOS. I'd also like to point out that in the samples directory, not only is there an XML file with the settings already saved for you, there's also a plain text file. This is the in file for MedFOS, and this is a sample in file for MedFOS-P. So you could manually copy the values out of this file and put them in for each option in the GUI and run it that way. But we're going to go ahead and load the XML file. Okay, and here we are. Again, we're going to change the size of the window so we can see what's going on. And what we see is that many options have now been set for us. So we have hourly temperature. Now this has been set to a value that works on my system where I developed the software, but it won't work on yours. So we need to change that file to be a different one. Likewise, the output files, we're going to put those somewhere on our system. So I created a directory on desktop here, which we're going to use, called MFP output. We'll set that. And there are a few other options we might want to look at a little more carefully. We'll see that there's a minimum and a maximum for several of these options already set. Some of these are worth setting, like sterility after intervention. This hasn't been set for some reason and is required, so we'd like to set that to true for temperature-dependent mortality. We're going to set a maximum number of flies that's quite high, maybe 100,000, to make sure that the simulation is complete. Okay. And I think those are the ones that are important. Now, there are a few other options that are special to MedFOS-P that you're going to have to set, and those are down here in the Run Options section. First is that the output files are no longer optional. This is actually required. So we've already set that because there's going to be many files generated as a result of the tens or hundreds or tens of thousands of simulations. Number of runs is the total number of runs you want to run for across simulations over the parameter ranges. So let's set that perhaps to 200. We also have number of threads. This is the number of separate simulation processes that you want to run simultaneously. On most systems, the best way to do this would be to run it, set this number to be the same number as the number of central processing units you have on your computer. So to check that in Microsoft Windows, you can right-click on the taskbar and go Start Task Manager. And in my computer, for instance, you see that there are 8 separate CPUs. Some of them are already being used, so perhaps I'll set this number to be a little bit lower, perhaps to be 6 simultaneous simulations allowed. Note that the more simulations you allow, the more system memory is going to be used. So, and also that if you set this number to be higher than the number of processors on your computer, you're not going to gain any benefit. In fact, the simulations will slow down. So we'll set that to 6. There's some other options here. Preview, this is if you wanted to just see the output of or the command lines that will be used, but don't want to actually run the simulations. We mean to run the simulation. We'll set that to false. And then there's a plot that gives you a live plot. We don't need to bother with that. We'll look at the plots in the output. And we'll say quiet. We'll set that to false so we can watch the progress. Okay, so now I think we've set everything. And we can do a preview and see what we've got. And what I'll let you know also is about a bug that exists in Microsoft Windows. And that has to do with the file system path separators. This will be fixed in the next release, but basically these backslashes that are put in by default by GUI Liner don't work. So you'd have to change these to forward slashes, at least the ones after the drive designation. As I say, this will be fixed. So these are all now correct. That'll work. And we can also look at output files and change those to forward slashes. Okay. So now we should be able to run the simulation, and when we do that we should see the processor usage increase dramatically. So we hit that, okay, and actually we had an error. I'm kind of glad that happened because this is a chance for me to show you that there was a problem. Program execution complete, errors reported. So if we look at the errors tab, problem with infile, the infile was not found. And the reason is, you can see right here, I neglected to put in a separator after the C, and as a result output got put in the wrong places. We have several problems. So I'm going to get rid of this. We'll delete those, and we'll try again. This is a good thing to happen because it might happen to you. So let's go back to the hourly temperature value, and let's make sure we have forward slashes on everything. Okay, and also let's do the same for the output. We have another problem here. Forward slashes for everything. Okay. And now let's try one more time. And we see that this time the program is running and appears to be running well. We have high processor usage, 1, 2, 3, 4, 5, maybe 6, I'm not sure. The GUI will show you how many simulations have been completed overall, and we can watch it chug through those 200 simulations that we asked it to do. 175. We should start to see the threads finishing now, and indeed we do. So the threads have now completed, and we also got our plots displayed, which is fine. What we have here on the left is a panel which shows the number of days that it took for the simulations all the simulations to run. We have an average right around 83 or 85 days, and this would be a histogram of the number of flies remaining at the end of the simulation. As you can see, there were none. So all of the 200 simulations had extirpation at the end of the time that you allow the simulations to run. So now we can look inside our output directory, and we'll see a series of useful results. The first are those histograms I mentioned to you, are saved as image files, so you can reuse those. We also have the simulation commands that were used. And again, the line breaks might not work correctly on your system, or they may. Here's a single simulation. Oh, there's another. So actually, let's use a proper text editor to see these. Okay, and what you see here is each line is a single command. So this is the command used to run a single Medfos simulation, and we should have 200 of these inside this file. So that enables you to go back and rerun a part of the simulations if required. Finally, there should be a LHS output file, which I think it put over here, probably to do with the path problem. And this is basically the file that was used to sample the parameter ranges. So you see those here. Okay, but the most important is this summary file, because this will contain what the information you're looking for in terms of your analysis of an actual outbreak. So if you look at that, you'll see when the simulation was started, when it was completed, the name of this file, various general information about the runs, and then here in the results section, these three lines are probably the most important. The percentage of simulations showing extirpation is 100%. The mean number of flies at the end of simulations was 0. Again, that goes with 100% extirpation. If you don't see these conditions, if you see that there's more than a very low percentage of simulations that did not show extirpation, that's an indication that there was not enough temperature data for the simulations to complete for there to be actual local extinction of your population of simulated flies. And that would give you reason to be suspicious of any estimate of the simulation length. Because if you ran out of time, you probably cannot accept that that's how long an outbreaks might last, or populations might last in the field. So we have the mean simulation run length in days plus standard deviation. And then here we have percentiles, which are probably the most useful. The run lengths for different percentiles. So at 95% means that 95% of the simulations showed extirpation before approximately 112 days. 99% means that 99% of the simulations showed extirpation before about 127 days. And as you can see, 50% is right near the average, is 85%. 85 days, sorry, for those to show extirpation. So that's, and then you also have down here some information on the parameters that were used for the MedFOS-P. So you have those set in there, and a citation. Finally, I also promised that I would show you how to get to the help. That's pretty straightforward. You go under the help menu to the MedFOS-P manual, and what you should see here is an HTML version of the manual, which you can browse, and you should be able to click on any of these links. It's a little more convenient sometimes in the PDF to be able to go in and see exactly, get information on the fly. You can click on the home to get back to the table of contents, and again, we have information on a lot of different parts of the simulation in here, or you can use the contents link at the top. Okay, and so that is the end of the video using MedFOS-P. Thank you very much.